What are the Northern Lights? Hi, welcome to Curious Kids Every Day. I'm Josh. How are you doing today? It's so good to hear from you. Hey, have you ever seen a picture of the night sky covered in long, glowing ribbons of green light? Have you ever seen a picture of that before? Believe it or not, that's actually a real thing. That's not a pretend image. That's a real thing that happens in the night sky in certain places of Earth. Maybe you've even seen a video of it before. Those lights stretch across the sky and they change shape, and sometimes they even can be red or blue or pink or purple. Maybe if you're really lucky, you've actually seen them before in real life. Those are called the Northern Lights. And you have to go really, really, really far north to see them, hence their name. I was thinking about this today because I got a question from a couple of kids in the Curious Kids Club named Levi and Archer. They wondered,
why does the Northern Lights glow? What is the Aurora Borealis?
the Northern Lights are glowing colors that can appear high in the sky, especially in places close to the Arctic. Their scientific name is Aurora Borealis. Can you say Aurora Borealis? Aurora Borealis. So, what are those lights? Well, they start 93 million miles away at a place called, well, I'll let you guess. What's something that's about 93 million miles away from us? It's very bright. Yep, it's the sun. The sun continuously sends charged particles into space. And this stream of particles and energy is called the solar wind. And this solar wind heads towards Earth. And when it reaches Earth, it encounters Earth's magnetic field. Now, we've talked on the show before about how the Earth's core, the center of the Earth, how it creates this enormous magnetic field around the Earth. And the Earth's magnetic field extends far into space, creating a region called the magnetosphere. Can you say magnetosphere? Most sun particles in the solar wind are deflected by the magnetosphere. But sometimes, conditions in the solar wind transfer energy into the magnetosphere. That energy can speed up electrons already inside the magnetosphere. Those energized electrons follow Earth's magnetic field lines toward the upper atmosphere near the northern and southern magnetic poles, the top and bottom of the Earth. When the electrons reach the upper atmosphere, they collide with gases such as oxygen and nitrogen. These collisions give the gases extra energy. The gases eventually release that extra energy as visible light. Lots of these tiny releases of light happening together create the glowing display in the sky that we know as the Northern Lights. The color of the aurora depends on which gas receives the energy and how high above the Earth the collision happens. Oxygen can produce green or red light. Green is the most common auroral color and is often produced between about 60 and 120 miles above Earth. Oxygen higher in the atmosphere can produce the red light. Now, nitrogen, it can produce blue, pink, and purple light, and colors from different gases can also overlap, which creates other shades. Earth's magnetic field guides the energized electrons toward oval-shaped areas around the magnetic poles. These areas are called auroral ovals. From the ground, the glowing areas may look like arcs, rays, or enormous curtains hanging across the sky. Changes in the solar wind and electrical currents around Earth can move the brightest parts of an aurora. That creates the shifting and waving motions that we can see. Northern lights are most common at high northern latitudes, but during stronger disturbances in the magnetosphere, the auroral oval can expand farther away from the pole. This sometimes allows people much farther south to see the lights. Auroras can happen during the daytime too, but sunlight usually hides them. Clouds and bright city lights can also make them difficult to see, so a dark, clear sky is always the best way to see the northern lights. The same process happens near Earth's southern magnetic region too. Those lights are called Aurora Australis, or the southern lights. So the northern lights are a colorful result of activity from the sun interacting with Earth's magnetosphere and gases high in the atmosphere. If you've never seen the northern lights before, I suggest you find a picture, or even better, a video, because they are amazing to watch. And it all starts 93 million miles away and also deep down in the core of the Earth. Pretty amazing. Okay, let's have a quick quiz and see what we've learned today. What is the stream of charged particles and energy flowing from the sun called? It's called the solar wind. And what is the name for the charged particles that accelerate toward the upper atmosphere to produce the auroral display? Those are called electrons. And what do gases release after collisions give them extra energy? They produce visible light. And do you remember what auroras in the southern hemisphere are called? The Aurora Australis. Let's play true or false. True or false? Most particles in the solar wind are deflected by Earth's magnetic field. Yep, that's true. True or false? Oxygen can produce both green and red auroral light. That's true too. True or false? Auroras usually form close enough to the ground for people to touch them from a mountain. No, that's false. They form high in Earth's upper atmosphere. True or false? Strong activity in the magnetosphere can make auroras visible farther from the poles. Yes, that is true. Would you rather travel north to see the northern lights or travel to space to see the moon? I've always wanted to go see the northern lights with my own eyes, so I would definitely travel north to see the northern lights. And then maybe I could hitch a ride to the moon another time. All right, let's play a round of What Am I? What am I? I surround Earth and extend far into space. Earth's magnetic field controls the movement of charged particles within me. And the solar wind can transfer energy into me and help begin an auroral display. What am I? I am the magnetosphere. All right, so today we learned that the northern lights begin with energy from the solar wind interacting with Earth's magnetosphere. Energized electrons travel along magnetic field lines and collide with gases high in the atmosphere. Oxygen can produce green or red light, while nitrogen can produce blue, pink, and purple light. We also learned that auroras usually form in ovals around Earth's magnetic poles, and that the southern hemisphere has southern lights too. They're called Aurora Australis. I've had trouble pronouncing that this whole episode. I've re-recorded it over and over. Aurora Australis. There we go. It's pretty neat that most of this stuff is usually invisible to us until it's not. The northern and southern lights are another amazing example of the amazing forces that happen all around us every day, and a lot of them we don't ever see. Until we do. What kind of question do you think we'll ask tomorrow on Curious Kids Every Day? I can't wait to find out. So until then, keep asking questions and stay curious, kids. And we've got some birthdays today. Georgie from Tennessee is turning 1. Happy birthday, Georgie. Anaya from California is turning 2. Happy birthday, Anaya. Rosemary from Washington is turning 2. Happy birthday, Rosemary. Teddy from Virginia is turning 3 today. Happy birthday, Teddy. All of these kids are turning 4. James from Oregon, happy birthday, James. James from Illinois, happy birthday, James. Augustus from Indiana, happy birthday, Augustus. And Henry from Florida is turning 4 this week. Happy birthday, Henry. Clara from New York is turning 4 this week too. Happy birthday, Clara. Eden from South Carolina is turning 5 today. Happy birthday, Eden. And Callum from North Carolina is turning 5 this week. Happy birthday, Callum. And all these kids are turning 6 today. Jude from Texas, happy birthday, Jude. Natalia from Massachusetts, happy birthday, Natalia. Charlie from Georgia, happy birthday, Charlie. Adelaide from Georgia, happy birthday, Adelaide. And Thomas from Peru and Puerto Rico, happy birthday, Thomas. Nora from Massachusetts is turning 7 today. Happy birthday, Nora. To all the grown-ups listening, if your curious kid wants their birthday mentioned on the show, please visit supportcuriouskids.com and join the Curious Kids Club. That's supportcuriouskids.com. See you tomorrow.